Okay, hi everyone. For our next talk, we will have another interesting topic want to share with you guys. So the next talk will about ScanCode to reuse free and open source software safety with free and open source software. We will have our speaker for this talk will be Ayan. He is the FOSS maintainer about code, and he also about the maintainer of ScanCode, the leading free and open source software composition in analysis and license scanning tool. So Ayan, it's your time now. Welcome.
Thank you so much. So let's jump right into it. So this talk is about scanning code and reusing open source software more consciously, more safely, and how we can do that with more open source software and open standards. So just what we are going to discuss, a bit of introductions, why we should scan code, and then how we can communicate about those scan results, and then some problems that I have faced, other people face, and how we can approach them or try at least for some solutions there. And then, of course, why should we use more open source tools for this open source discovery and identification? And then we'll have some questions at the end. So about me, I am Ayan. I'm a core maintainer of ScanCode. That's my full-time job to maintain these tools, and I also maintain some other tools at About Code. And I work on mainly license identification, package identification, and summarizing scan results. So About Code is also an organization in Google Summer of Code, and that's also how I got into open source maintainership. I did my Google Summer of Code back in 2020. And since then, I'm a mentor and org admin there. I have a couple of links in the slides, so there'll be a QR code at the end to download the slides. Okay, so About Code. About Code is it's a non-profit organization, and our mission is to build FOSS tools, open data, and open standards, so we can look into our open source consumption and use. And we have, like, I am new to this, but the original authors and maintainers have been in this space and in this community for a very long time, and this is a fully community initiative, and we've been creating a lot of standards, open standards to help people in this space. And we also, some of our maintainers provide support services, and we audit or help organizations look into their code and understand how they are consuming open source to sustain ourselves and maintain these tools full-time. And so we, in this modern software world, we are using more and more FOSS tools every day, and that's a good thing. We are reusing things. We are not working on the same, like, yeah. And then basically, that's a good thing because we are working on our collective technical capabilities. And like, if you're using a software and it's a small package, you'll see typically hundreds of packages. And if it's a very large app with multiple ecosystems and everything, the scale can go very big, very fast because of the whole dependency graph. And we always see, like, large apps, if we scan, there's 10,000 packages, there's like millions of individual code files. So what it clearly becomes very, very clear very soon. This is not sustainable to look through all of this manually or through just through people. You need some sort of automation and help and tools to really navigate through this. And as an open source organization, our goal is to help with tools and data on that. Then, okay, why is software license important? So here, FOSS means freedom. So what freedom do you have? And what responsibilities do those freedom bring to you? Can you use those software in different conditions, context, and then can you modify it? And if you're modifying it, do you have to redistribute the same code, and can you relicense it, or do you have to redistribute it under the same license or something, right? Sometimes you also have to give credit. You also have to attribute all the licenses that are present. And like Biju has already talked about issues in licensing and like issues that can happen, so I'm not going into that. But like, why is this important from a security perspective? Like, if something, there's a license issue, and you cannot use that package or something, it is also an availability issue. So that can really affect your like package and software. So it's really important for that reason also. Why do we need to identify what exact package do we have? Because as you can see here from the Redis blogs, and these are taken 5-6 years apart, they had an open source license, and then, of course, like sometimes things change for people, and then they adopt a different policy. So I'm not here to talk about what this is or what this can be, but like you have to be aware that this thing can happen, and it happens more than you think, because like there's the Redis example, there's the Elasticsearch example, there's the Terraform example, but like sometimes the community will fork the latest open source version, and then they will maintain it. For example, Valkey is a Linux Foundation project that is there to replace kind of Redis. There's OpenSearch for Elasticsearch. There's OpenTofu for Terraform. So we need to really identify where the package is coming from, the origin of it, so we can know what could be the license. Now, in case of vulnerabilities also, vulnerabilities, advisories are published by different sources, and they typically have a vulnerable version range. So it starts at a version, ends at a version, and it can be fixed by a specific version, and sometimes it's not fixed because it's not there. And you see on the right, there's the GitHub advisory database, which is a nice database, and you have affected version ranges there. There's a couple more data there on scores, severity, references, and on left, there's the public vulnerablecode.io database, which is an open database which collects and processes this, aggregates this data so that you can search by package URL and query what vulnerabilities are present. Okay, now there is another kind of problems that is not really related to vulnerabilities directly in code or like licensing, which is how well is a software maintained. Because sometimes there can be issues in like how the code is maintained, do they have good security policies, and there a lot of bad actors also kind of attack those things. And like here, there's a lot of nice FOSS project. OpenSSF does a lot of nice work on giving you data on that. They also have a open data API, so you can get, so they have what you call a criticality score for projects, and the critical projects, they publish data for that directly, which you can access by the API. For example, ScanCode is a critical project, so OpenSSF has data on that. And then there's end-of-life date, so you really need to know when a software is not maintained anymore, so it's end of life, and there's also open data on that. Chaos, the community does a very good job of looking into this metrics in a very detailed, granular way. And they have these projects here, Augur, Grimoire Lab, which you can use to get more insights on these metrics. But at the end of the day, it's just metrics. It is data that you can look at. And of course, if you are like maintaining a project very nicely, chances are that you are also looking at security very well. There's at least a correlation that you can see in studies that the projects which are maintained well is also secure. But there is no direct like actionable thing that you can see that, okay, there's some data and this is not maintained, I need to look into that. So you need a bit more context, and we'll talk about that. Hope I did not use too many XKCD comics. Okay, so now you have a software. You're ideally building a software or package or consuming, And then, so what data do you want on it? So you want what are the licenses present there? You want what are the vulnerabilities which can be present? You want some data on how well it is maintained. And you ideally want this for the entire dependency graph because whether it is direct dependencies or transitive dependencies, your computer does not really know that, this is quite few levels down, so I will not look at the vulnerabilities or I will not run the vulnerable code. But of course, you use a sometimes very short subset of the actual code that is present in packages. And the many layers, if you go down, that risk becomes a bit less. But you still need to look at all the dependencies because even transitive dependencies, how many layers deep they might be, they still have access to your system or build systems in the same way that a direct dependency would have. So that's one thing. So also you need to know where exactly the package is coming from, what's the origin. And whatever we were talking about right now, this is basically what is there in software bill of materials or SBOMs. You need this data to be machine readable, right? Because of the scale that is present in modern software, it needs to be machine readable in a way which is understandable by everyone because software crosses boundaries and geographical locations, and we need to make sure everyone is talking the same language here. So SBOMs are really looking into software transparency. Because software is typically used in a lot of critical things. It can be present in your network infrastructure, it can be health tracking devices, everything. And you ideally want more transparency into what is in your software there. So that is where SBOM comes in and adds a lot of value. Now, it's also because there's a lot of law and regulations which are coming up on this. In US, there was an executive order which mandates SBOM for any business or commercial activity you do with the government, so you're selling them software. And then Europe, we have CRA, which comes into effect quite soon. And there's there's some granularity on who it is affected by. And there's maintainers, open source stewards, and manufacturers. And typically, if you are having some sort of commercial benefit from your project, either you're getting funded for your maintenance or you are selling that as a unit, then you might be directly affected by that. So that's something that you need to think about. In India, where I come from, there's also CERT, which is the Computer Emergency Response Team, which looks into security incidents that happens there. And it has published guidelines on how SBOMs should be. And usually guidelines have, minimum requirements and a bit of guidelines on how you should go about in generating a SBOM. There's also the SEBI, which is the Securities and Exchanges Board of India, which regulates all financial institutions and digital infrastructure providers. And they have published what's called cyber security and cyber resilience framework, which goes into that you need to disclose some incidents, you need to publish SBOMs if you are a regulated entity, which means banks, financial services institutions, mutual funds, all of that, right? So it's not that it's in the law very recently, so SBOM is a new thing. People have been doing this for quite a long time. When they look into products, they need to have a complete inventory of all of things. And maybe people were doing it in spreadsheets or something, which is, of course, not a great way to do things. Now, similar legislations are likely to come up. I know some legislation is there, guidelines in Japan, in Germany, in UK, that has come up recently. So it's typically getting more and more common. So what do we need to really generate these SBOMs? We need some standard package identifiers. And here are a couple of mentions of the most common ones that you can use. So package identifiers are package URLs. SPDX maintains a license list of identifiers across all ecosystems. And then for vulnerability, you have CVEs. or GitHub security advisories, which are IDs by which you can uniquely identify something. And for SBOMs, there's CycloneDX, which is typically more focused on security, but SPDX on licensing. But they are, in the later versions, they are more supporting everything else. And we are active in these communities. We have the vulnerability exploitability exchange, and then there's a couple of formats. And so package URL was started in ScanCode because we needed to really identify unique packages to then look up in our database and look for licensing and get the original source and binaries for those packages and then scan them, right? So typically the type here is kind of a package ecosystem which hosts some code and has some standards and specific ways how you can download that thing, which can be PyP, it can be like the Linux ecosystems, Debian, RPM, and then so inside that there can be like organizations in namespace. Name version is mostly self-explanatory, and there's verse, which is another standard which looks into version ranges. And you would think, well, version ranges is just arithmetic. Why do you need a standard in that? But there's like a lot of versioning specs like Semver, Calver, which are very different, and then people move between them whenever they want, so things can get very hard very soon. So are these just more standards that we came up with, or like are they being used? So the answer is yes. Now, even though it was started as a ScanCode thing, it is really in the truest sense a community projects now, because there's a lot of community. Whoever uses, they recognize the value of this identifiers and standards, and a lot of tools, commercial and open source, are using it, which is good for interoperability because you really can see what the differences, have benchmarks, and see if they are being followed or not. So this is something that Michael Windsor, who is from the Alpha Omega project, he did a talk in FOSS about code, actually hosts security and license compliance fringe event there, where he talked, and he talked in FOSSDEM also. And here, let's say you have some packages that you are using, and you are getting some value out of it. So then you also inherit some risk from them. So how do you go about interacting with these dependencies? So of course, if you are getting some value, and that value can go away with risks, so you want to make sure you invest a bit of your time and go engage with the maintainers, go report issues, open PRs, so you can really help them upstream, and that can really benefit. So that's fix. If for some reason they don't like your code or don't want to maintain it in long term, or if their timelines are not really matching with yours, you can fork, and it can be for a short term, and like you maintain a bit of that and forget. If some open source dependency is creating more problems than the value it brings, then you try to find other projects in the similar domain that can do the same work and have the same effect, right? And of course, there's a fourth F, which is fund. Open source communities like ourselves always have a lot of ideas and work that we want to do, but sometimes resources can really help us in that direction. So what this really focuses you to do is have a nice human relationship with our dependencies, because you can be like in their like issues and mailing lists, and you can have a chat about them, and that gives you a lot of insight into who these projects are. That makes you more conscious, because whenever you import a dependency or add something, you unconsciously add a lot of dependencies inside your dependency graph. And if you have a relationship with them, even like human, you see them at a conference, you know them a bit, and a human relationship makes you have more context into what happens into these projects. And that makes you gauge the risks better and even mitigate and help them fix. Because like sometimes if people come up to me and say that, I'm using your tool, I'm using ScanCode, that makes me very happy. That makes my day. So if you come up and if you help them do some project or like help them with issues, that's really nice. So human relationships help everything. So now getting into a bit of the problems. So you can scan code in many ways. You can scan it at the binary stage. You can scan it at the source stage. And binaries typically just have enough to run the code. And like they are catching up and having some metadata. But it is usually a bit less than what's present at the source. Because in binaries, you have to have some sort of system to have that information feed into it. And in source, it is not very clear what part of the subset of the source is actually deployed and present in the binary, because source can have monorepos, it can have test or like some examples or something. And people always don't follow the standards there and structures which can tell you which part of the code is deployed. So here the thing is that whenever you build your code in the build systems, they typically have a lot of information on this place. And like, for example, there's build SBOMs, source SBOMs. And like, since the build systems have a lot of information, it's very nice to do your scans and do your information like scanning there. So you get the most amount of information. And since you do a build for every release, it's also nice to generate the SBOMs for every release there. And one more thing is, typically all the like code scanners that you see out there which look for packages, they only look for package manifests. And sometimes your dependencies might not be declared there. For example, we vendor a lot of code, and vendoring can be a good thing in some cases because you want only a very specific subset of code. But people don't really document that. There needs to be some way and standard to document that, yes, I have downloaded this code from somewhere, and then it becomes very easy to track the license metadata, track the vulnerabilities for that specific thing. So those are some problems. And like, for example, there's also a lot of package ecosystems present there. For example, in ScanCode, we support about like 30, 40 package ecosystems, and package URL, there's like types like PyP, Debian, there's many of these. And in every ecosystem, you have a lot of like sub builders. Like, for example, PyP has poetry, there's like many different kinds of metadata. And it's not that it is a stable thing. Like every day there's like problems in the package ecosystem. So like we come up with newer ways, newer package manifests. So there's a lot of work that we have to do to support scanning those manifests and make sure the package information that we get out of it is very nice. And okay, vulnerabilities. So typically, if you are scanning for vulnerabilities in a large app, my experience is that the data is so much that we get overwhelmed by it. Like, if like all the dependencies that you have on all your dependency graphs, and they have multiple CVEs sometimes, and how can you look at this? Like, first, there's the fact that even if there's a vulnerability that a scanner reports in your code or dependency graph, it does not have to be that that affects you, because the vulnerable code path might not be used. So it can be the case where you use only a subset of the code, and that becomes more and more apparent with deeper you go into the dependency graph. And also, sometimes some CVEs or vulnerabilities are only applicable in certain configurations or certain environment variables and contexts. So if you only deploy it as some, like, in a web-based thing, it can become apparent there, but not in other cases. So you really need to know if it is applicable to you. And you need to know this like one more thing is there are like more data available on this. For example, exploitability. There's EPSS, which means exploitability predictive scoring system, which kind of predicts how likely it is to for a vulnerability to get exploited. Or there's like databases of actual vulnerabilities being exploited in the wild. So or severities across different ecosystems. So these really help you to prioritize, because when there's a lot of data, you need to really prioritize which ones you need to look at. But typically, they do not give you a very clear indication that this is not applicable or applicable. So you need to sometimes look beyond that as well. So how are we going about this differently, or why do you need to use open source tools for that? So the thing is that your entire dependency graph, there's a lot of small open source projects out there, right? And all these vulnerabilities, if a vulnerability is not applicable in their context and you are using a specific version, it might also not be applicable to you. So this work needs to be done upstream, and then it needs to be in a machine readable format and needs to be fed into this, right? So these tools, this data, all of this needs to be available to all tools as a free thing, and they must have that freedom to use and be helped by these tools. So it's very, for example, commercial tools require much more resources. So your entire supply chain might not have access to those resources to do these fixes and look into these tools. And so that's why it's very nice to work with these package ecosystems and make sure we are working with them, like let's say PyPy or Debian, to have better metadata and more transparency. We also, like different organizations, they might have the same dependency and they might be doing the scanning for the same tool and might be doing the same analysis. So we need to have more open data so we can share among each other and have some sort of collaboration so we don't do the same work twice, right? And then, of course, you need to have a large community who look at all the use cases and report to you and help you get better, because if you have that, you are really making your tools much better. So that's why you should focus on open source tool. We have less time, so I'll skip through some of this. This is the stack. A lot of organizations, most FOSS foundations like Apache Linux, Eclipse, all of them are using this. A lot of commercial companies also use open source tools, and we know this because they also openly support us to sustain sometimes. And we are also having collaborations with many FOSS organizations, like Hugging Face is using this to have a license database of permissive code to train LLMs. We are working with these folks, and there's a lot of other FOSS tools. You don't need to just use our tool. You can use this amazing other FOSS tools. These are out there, which sometimes also uses ScanCode as a dependency. We need your help with a lot of bug reports, help, and if you can help us sustain these projects or anything, it's nice. And you can download the slides or look into our GitHub here. And these are the credits, and maybe we have a time for some questions.
Thank you a lot for all your sharing, Ayan. Unfortunately, we just run out of time,
okay, no
and it's also over time with the next speaker.
Okay, no
so
worries.
we really want to say thank you for your
thank
sharing.
you.
I believe our speaker
Yes.
will be around. So feel free to reach out to him if you guys have any questions relay into the talk of Ayan and ScanCode. So thank you so much for your time.
And thank you to FOSSASIA for organizing this nice community. Thank you.
It's our pleasure.